Rheology. Rheology is the study of flow and deformation of materials under the effect of an applied force. Ideal solids to form reversibly. The energy required for the deformation is fully recovered when the stresses are removed. Ideal liquids to form irreversibly. They flow and the energy is dissipated in the form of heat. Rheology is applied for quality control of polymers, improvement of the processing behavior, optimization of the end product. Viscosity is the resistance to flow. Viscosity can be calculated as the stress divided by the shear rate. In this respect, there are several models used to describe the behavior of stress and viscosity versus shear rate. In the Newtonian model, the stress varies linearly with shear rate. In other words, the viscosity is constant and independent of shear rate. In contrast, Bingham, pseudoplastic, and dilatant materials show non-Newtonian behavior. Some non-Newtonian materials require a certain stress to flow, the so-called yield stress. This is usually related to structural changes induced by shear. The shear rate range to be studied depend on the industrial processes involved, and they should be taken into account for viscosity measurements. Oscillatory measurements are used to explore the viscoelastic properties of a material. From these measurements, the complex, storage and loss moduli, as well as the phase angle, can be determined. These parameters give information on the viscoelastic and gel-like properties of materials. A strain sweep is used to measure the linear viscoelastic region, LVR. From a strain sweep, the cohesive energy, CE, can be calculated to determine stability. The larger the cohesive energy, the more stable is the material. The rheology of materials is also time-dependent. Creep and recovery tests consist in the application of a constant stress followed by a period of zero stress. During the test, the strain is measured as a function of time. The compliance is defined as the ratio of the measured strain to the applied stress. The greater the compliance, the more the material can be strained under the application of a certain shear stress. For more information, visit us at iqac.csic.es/qci/.